I hope to offer you my experience and to be at your discretion. This lecture is certainly sponsored by prestigious training center, Universal Petroleum Training and Consultancy Solution. Today, we are going to talk about an introduction of oil and gas process safety, which help the attendants to understand the subject to obtain more easily safety, enable general process safety, also process safety management, oil and gas, in NEBUSH, also CSP and ASP. Okay. Let's start our presentation. At the first, we must know the content of this lecture, which consists of the following. The first is process safety management meaning. Then, to understand everything about the studies related to process safety, we will discuss one of the world's worst industrial disaster. World worst industrial disaster, which is called Bhopal tragedy, which is the main reason for global movement on process safety. So we will talk about Bhopal gas tragedy, Bhopal disaster, lesson learned. But what are the lessons learned from this lecture? Firstly, to easily understand the meaning of process safety and to differ between the process safety and occupational safety. Also, you will learn about the most important accidents and how to analyze them and the importance of learning for government, companies, individual from the incident lesson learned. Okay, now we need to know the meaning of process safety. But at the first, we will distinguish between process safety and personal safety. Let's start with personal safety, which give the same meaning of occupational safety. Excuse me. Okay, the personal safety, which give the same meaning of occupational safety. Occupational safety is focused on the safety, health, and welfare of people at their workplace. And to understand the occupational health safety, we will talking about some identification related to occupational safety. As you know, that the HSE is referred to health, safety, and environment. When we back to the general NEBUSH as a reference for us, we found the meaning of health is the absence of disease or ill health. For example, asbestos create a health risk because if you inhale asbestos dust, you may contract lung cancer. As you see in this figure of the health, you see here not a physical ill health, but you see psychological ill health. Because this worker is suffered from too much stress, which can lead him nervous breakdown. Also, the safety meaning is the protection of people from injuries or is the absence of uncontrolled hazards, unacceptable risk, and significant risk. Regarding welfare, is looking after people's basic needs, providing welfare facilities, as you see in the figure, like toilets, hand wash station, changing room, and others. Also, it's important to know the difference between the meaning of risk and hazards. About the hazards, it's mean any event that had potential to cause loss, like working at height. If you're looking at the figure, this making cutting, and this is one of the occupational risk tests. And the risk means the combination between the probability of hazard and the severity of that hazard. You show here in the probability and the severity. So from this figure, you can get that the risk score is equal the probability multiplied by severity. This is one of the methods of the risk assessment is called quantitative risk assessment. For understanding the meaning of risk, I will take the example of working at height hazard. If you're working at height, the potential probability of falling will be increased if there is no precaution sets to prevent or reduce its probability, and the consequence will be increased if the height will increase. Finally, again, the risk is equal probability multiplied by severity. Again, back to the meaning of important rules in industry. Of course, there is some codes taking a legal phase and provide a good practice for implement occupational safety. Again, after I define the meaning of hazard and risk, and it understood by organization, now the organization should set precaution and action to reduce the risk of injuries and ill health. And the best way to follow the hierarchy of controls, as you see in this figure. But start to set precautions that eliminate hazard if it's possible. If not, use other methods like substitution, engineering, and administrative control. But you should know that the BBE is the last defense line of hierarchy of control. Why it is the last defense line of hierarchy of control? Because it doesn't eliminate the hazard. Because it is personal use. If we're talking about the example of working at height, so we can say that the BBE like helmet will not prevent the falling object to be done. It's okay? Is it clear? Okay. So I will give you the first question. Or you can say assignment. Please answer it in the comments after the presentation completed. Why the BBE is considered as a last defense line of the hierarchy of control. Why the BBE is considered as a last defense line of the hierarchy of control. Okay, back again to occupational safety. We found that all examples and hazards of it may be too high, the probability of hazard, but consequence not raised to be catastrophic. But the consequence not raised to be catastrophic, which means it gives concern to safety and health more than environment. We will show in the page later. After I describe the meaning of occupational safety, so now we need to know the meaning of process safety. We need to know the meaning of process safety. There is many definitions of process safety, and I will say one of them, which is referred to NABUSH process safety standard. It is blend of engineering and management skills focused on preventing catastrophic accident, and near miss, structure collapse, explosion, fire and toxic release associated with loss of containment of energy. Also, it's focused on the hazards involved with industrial process and preventing catastrophic accident from either, such as unintentional release of hazardous material. Finally, all of the activity related to process safety, maybe it's too low probability of hazard, but consequence may raise to be catastrophic. We will take one example for this is Bhopal disaster. It's a given concern to the safety and the environment more than health. These three figures is showing what I said before. We will find here that this is a frequency, or we can say this is a likelihood, and this is the severity or consequence. We will show that the process safety, the consequence in the process safety will be raised, may be raised to be high, but in the personal safety, the consequence will not raise to be high. In the process safety, the probability maybe of the accident may be rare, but in the personal safety, the probability maybe it's too high. Also in this figure, we will show that the personal safety is concerned about health and safety, but process safety is concerned about the safety and the environment more than health. In this figure, We will show some examples of personal safety and the hazards of personal safety like slip, trip, and others. But the process safety is too much difference. This is concerned about leak or release of containment. Release of containment. I think now it's clear. So the second question is, what is the difference between personal and process safety? What is the difference between personal and process safety? Okay. In this slide, I will talk about Bhopal and the global movement on the process safety. The Bhopal disaster was a toxic methyl isocyanate leak. Remember, MIC is the methyl isocyanate leak. This is a toxic gases, okay? Remember this. The accident happened on the night of 2-3 December 1948 at the Union Carbide Indian Limited pesticide plant in Bhopal. As you see in this figure, okay? It is also considered among the world's worst industrial disaster. Worst industrial disaster. And the official immediate death was 2,295. So the official immediate death was 2,295. Now it is important to know the Bhopal gas tragedy for help us to make analysis and identifying the risks and what is the best practice and precaution taken as a lesson learned for individual organization again. Please keep listening well with me and concern to the screen. In 2 December 1948, operator began routine maintenance. As you see in this figure, here is the tank of methyl isocyanate E610. This is a jumper that had been erected. Here, the operator began routine maintenance activity in the factory owned by Union Carbide Indian Limited. Washing of pipes was performed to keep a filter system clean by flushing containment out with water. Then the water reached a tank of highly reactive pesticide. The water reached the tank. I mean, it's backflow as many possible, but the most accepted theory of the overflow devices downstream from the filter was blocked. The filter was blocked, so it caused backflow to the tank. It's okay. The water flow back to vent system through leaking isolation valve. Water traveled 100 of meters of pipe from the filter, eventually reaching storage tank E610, which containing 42 tons of methyl isocyanate. So in this figure, we will show that the first problem is the slip blind is passing. Then the second problem here, the operator ignored the pressure gauge connected to the tank as he assumed that the gauge given faulty reading. As he assumed that the gauge given faulty reading. This is depending on the competency of the operator. Don't forget that. Because the problem here that the operator ignored the pressure gauge connected to the tank as he assumed that the gauge given faulty reading. Also, there is no way to monitor the tank temperature. As you see in the figure, that the temperature measurement not available. Temperature measurement not available. Okay. Also, the pressure of the tank was supposed to maintain at certain level with inert gases to prevent backflow. Here, the inert gases. If the pressure increased, we should inert gases to be intervention, like nitrogen hoses to keep the pressure in the way. Okay. Also, there is a leaky valve connecting the tank to the plant main pipe system. Here the operator noticed, that actual condition inside the tank, it was too late to stop loss of process containment. The deadly gas drifted downwind into surrounding community, causing deaths for thousands of residents in Bhopal, leading to what is known as world worst industry, a disaster. Is it clear now? Okay. But why we study this accident? To gain a learning outcome. So, this is several lessons learned are presented below. Start with assets integrity and reliability, process hazard analysis, inherent safer design, pre-stop safety review, employee participation, leading and lagging indicator, emergency response plan. Firstly, the assets integrity and reliability, where it's showing may failure in equipment and instrument devices, and we can summarize as follows. The refrigeration here, the refrigeration system was turned off. So it is difficult to control the heat resulting from ectothermic reaction caused when water reacted with MIC and resulting in runaway reaction. As I said before, remember that the MIC is a methyl isocyanide. Here, the water is react with MIC, causing ectothermal reaction, the exothermic reaction causing thermal runaway. And the refrigeration system is not working, so it cannot control this heat and cause the thermal runaway. And the tank high temperature alarm was not functioning, and there is no heat detection, so the tank high temperature alarm was not functioning. Also, the vent gases scrubbers, VGS, vent gas scrubber, was under maintenance, where the leaking gas could have been detoxified, but the scrubber was also turned off. Tank E619 is evacuation tank, but wasn't empty. Look, also the evacuation, I mean by evacuation, it's emergency tank. When this tank E610 is fully and faced a hazard of thermal runaway, it should be drained to the evacuation tank. But the evacuation tank also is not fully, wasn't empty. Also, pipeline were allowed to corrode because it's made from iron. All of this pipeline is made from iron, so it's easy to corrode. Water certain, this is water certain. Not high enough to reach gases. At its height is 10 meters, where it is not tall enough to reach the stack of VGS vent gas scrubbers, which had 13 meters high. In addition to flare was disconnected from the plant pipeline. Also, this flare tower is disconnected. So what is the connected? All of the system is disconnected and shut down. So which the system will be controlled and mitigate the consequences? Nothing. Finally, it found that all valves, vent line, and feed line were in poor condition. So it found that all valves, vent lines, and feed line were in poor condition. Secondly, the investigation here recommended and give importance of the following: the inherent safer design for avoiding avoiding hazards at source instead of controlling them. Avoiding hazards at source instead of controlling them. By applying the inherent safer design, it's provide for approach. As you see, 1, 2, 3, 4. One, by minimize or use a small quantity of hazardous substance. And regarding of this approach, it can use intermediate inventory as it is not essential as a raw material nor a product. The second approach to substitute or replace hazardous reaction with another of less hazard. And this approach applying by use a safer route by reacting alpha naphthol and phosgene